In this video, we're going to talk about strategy books. If you have received the materials, you should have the strategy book. So this strategy book have all the teaching strategies for addition, subtraction, multiplication, division, and some of the fraction problems here. So if you don't have your strategy book with you, I strongly recommend you to print out the strategy book from the canvas and make your own, because we are going to use a lot for the operational problems. Okay, so if we want to make a strategy book, what you need to do is go to Canvas and download the strategy book template. So you can print out some of the pages from the strategy book, and you'll see this has to be front and back. So you see front and back, and you see the bottom of paper use the table numbers. But remember that this is a booklet format, so number does not go 1, 2, 3, 4, 5 like that. If you print out everything, then your number will meet the sequence. So you can print out all the pages from the strategy book template, and then you can make a stack of this. Something you see the numbers on here. This is 4, and this is 2. So the 2 and 4 and 6, 8, 10, 12. 16, something like that goes on top. And after you print out everything, what you need to do is fold this paper like this. So if we have face up all the even numbers here, and then you can fold it up here, then you'll see the numbers go 1, 2, 3, 4, 5, and it's just gonna keep going. So print out all the papers front and back and fold in half, then you will see the booklet for you. So you can make your own. And there's another separate page for the cover. So you can make your own cover, but this is how I use for the strategy book. So you can have this together and fold it, then you're gonna have your own strategy book. Okay, so you can go here, and you can use it for the lesson. Okay, so try. And so this is the strategy book everybody should have, but the first cover must be blank for you, because I want you to decorate your own strategy book. So this is my book, so you see the name Hannah Kang bottom there, and actually my daughter helped me to decorate with all the stickers. So you can use anything you have in your room, your drawers, decorate your strategy book. So you can name it whatever you want to name it. You can say my math journal, my math book, my math strategy, or what strategy would you use like this. So it's gonna be your book. It's gonna be your resources you want to take away from the class. So enjoy decorating the time. Okay, so this is what you're gonna see if we have a strategy book. The first page I want to talk about the need help here. So in this math method class, I really want to stress out whenever they solve the problem, they need to explain how they solve the problem. That is more important than getting a right answer. I want them to know, be able to explain how they solve the problem and why this is the answer, why that is not the answer. Justify their reasoning is the most important part when they're working on the strategy. But a lot of time, if kids don't have enough practice how to do that, maybe they're not able to do it, or they just need some help. Or if they're ELLs, then they need some kind of starter sentences or some kind of guidance how to explain their thinking. So you can make your own rule for your classroom. This is how I did it. You don't need to have everything I have here, but this is an example. So everybody should have the example, but you can make your own tips. So you can build a classroom culture environment for your students as well. So I have some sample sentences how to explain your thinking. Sample sentences, and what I did first was blah blah blah, and then I did this and that, and I noticed that this and that, and I think there are how many fish on the fish tank. So that you can, if you give them some sentence starters, some guidance, kids will have better understanding and how to explain their mathematical thinkings, and they can build practice through this. And then you can also have them make your own tips in mathematics classroom. A lot of times, if we focus only on right or wrong answer, then sometimes they feel anticipate it because I don't know the answer. But if we build a classroom culture, everything you say is valued. We're trying to find the answer together, and multiple strategies are valued, and then those kind of structure makes them feel comfortable in your classroom. That's very important in mathematics classroom. So you can think about some of your own tips. For example, it's okay to make a mistake. Is it true? Then you want to say it's okay to make a mistake in math class. That's how we learn, right? So struggling is the best way to learn. Something like that. So you can give them some encouragement how to, share their thinking in mathematics classroom in public. So that's something you can think about in your classroom. So this video particularly talking about addition and subtraction. You're going to continue to multiplication division next video. So whenever I start with a strategy book, I always start from the smaller number and concrete way, then basic one, and then move on to the little bit more advanced problems and strategies. So this is the kindergarten and first grade classroom kind of problem here. So here's the problem here: single digit addition and subtraction strategies. So there are 6 goldfish and 7 angelfish on a fish tank. How many fish are there? So I'm going to talk about a couple different strategies here. The first one is named direct modeling. Okay, so direct modeling is the basic concept, the basic strategy, most basic strategy for the students. They want to use drawing. They want to draw out something. So they're going to draw out. There are 6 golden fish, so they can use fish tank, but sometimes, you don't want them to spend so much time on drawing, not learning mathematics, especially for first grade girls. They want to spend art project a lot of time in math class. So you may want to think about it, it's okay. You don't need to draw like a really nice fish, right? So they can draw kind of box, and then they can draw 6 goldfish, 1, 2, 3, 4, 5, 6, and they're gonna draw 7 angelfish, 1, 2, 3, 4, 5, 6, 7 angelfish, and they can count how many they have all together. All right. So that's how I got the answer. I need a drawing. I need to draw something, or I need a concrete object, like counting chips, or manipulatives or some kind of things, concrete model. I need to be able to tell a number. Without the drawing or concrete object, I cannot say my number. So that's the kind of direct modeling. They need to draw out something, circles or whatever they can represent fish. And the counting strategy. So this is a little bit more advanced than direct modeling. Think about if you go to kindergarten or first classroom, your first grade classroom, you're gonna see a lot of them are using their fingers, right? So 1, 2, 3, 4, 5. They're using fingers to counting. This is very handy because they carry every time. So counting strategy, most common strategy you probably see in your classroom whenever you give them subtraction or multiplication, addition problems for that. So I have 6 goldfish, so I'm gonna add 7 more. There are 2 different ways. So I can hold 7 in my head because I know that that's easier to count. So I can holding 7 in my head, and I'm gonna count 1, 2, 3, 4, 5, 6. So I counted 6 more. Do you see how I did it? So I hold 7 in my head, and I go 1, 2, 3, 4, 5, 6 more, and I end up in 13. So my answer is 13. What about here? Just exactly the problem says here. So I have 6 in my head because I have 6 goldfish. So I have 6 in my head, and then I'm going to count up 7. Right? So I'm going to have 1, 2, 3, 4, 5, 6, 7 angelfish. So I end up same as 13. So this is different way of counting, but basically they're going to hold one of the numbers in their head, and I'm going to counting up to get to my answer. Okay? So this is more abstract. Why is that? Because the first one, they need to have some kind of concrete object in front of them, but this one, they don't need to have that. They don't need to have 7 things in front of them to know this is number 7. They already know the number in here. So it's a little bit more abstract in here. So this is a counting strategy. And number fact, this is a recall. So they somehow from their earlier experience, from their siblings' textbook or TV show, Sesame Street, and other game tools, they know this fact already. So 6 plus 7 is 13. So they don't need to do anything. I just know from my memory. So that's the number fact. They recall the memory. And another one is number bonds. Number bond is kind of new and it's very popular in a lot of many textbooks. So that's why I want to introduce now. But if you're not sure the number bond in here, that's okay because we're going to talk about more in the multi-digit. And if we practice multi-digit numbers using number bond, this makes more sense. I don't know why, but it's more sense than this one in here. But the key idea of number bond is we are trying to use groups of 10. Why do you think we are using groups of 10? Because groups of 10, that's our number system place value. We need to make groups of 10 to do the operations, right? Regrouping, carry, and borrow is we are all trying to make groups of 10. So that's why we are trying to make groups of 10 as early as possible. That's what we are trying to do. So here, I want to do 6 plus 7, right? And I want to think about what number going to give me a 10 if I borrow something from 7. If I break down numbers into some way, I need to make a 10 from 6. Then remember to talk about the number sense and place value. I ask you to practice a lot of breakdown numbers apart. This is why they need to know breakdown numbers apart in many different ways. It's going to be really easier if they have enough practice of breaking numbers apart each other. This is a more easy strategy for them. And also when you talk about the fact family, 1 plus 9, same as 9 plus 1, 2 plus 8, or 3 plus 9, 12, 12 minus 3 is 9, something like that. But I strongly recommend you to practice fact family around 10, because that's what we are trying to use. 10 plus 90 is 100, 1 plus 9 is 10. All our number system is built around groups of 10. So whenever you want to practice fact family, I strongly recommend you to practice fact family of groups of 10. That's the best way to practice fact family. Okay, so I have 6 and I need 4 more to make my 10. So I'm going to break my 7 into 4 and 3. So 7, it break into 4 and 3. So 6 plus 4 makes me 10. And I have 3 left over here, so I'm going to add 10 plus 3 is 13. Does it make sense? What did I do? I was thinking about 6, and then what number should I need? Do I need to make my 10? So I need 4, and then the rest, so I have 7 in here, break into 4 and 3. So 6 plus 4 is 10, and then 3 here, so I'm going to have 13. Does it make sense? We are going to practice a problem, so if you're not sure, you can practice in the practice problem here. And derived fact. So this is something they use their prior knowledge here. So students already know some kind of fact. And the researcher says they're really good at using doubles, like for multiplication fact or addition fact, they know double very well. So 5 plus 5 is 10, 6 plus 6 is 12. They already know those kind of number fact. So that's what they're going to do. Use. So I know that 6 plus 6 is 12, right? And then 7 is 1 more than 6. Because my question is 6 plus 7. So she knows that 6 plus 6 is 12. And 7 is 1 more than 6. So I'm going to add 1 more to 12, which is 13. Okay, does it make sense to you? So I use double fact. Fact of double. I know that 6 plus 6 is 12. So I'm going to use those knowledge to drive the answer. So 7 is 1 more than 6. So I know I'm going to add 1 more to 12, which is 13. Okay? So now, this is invented algorithm, something very creative, something you don't see in here, something different than here. Students can develop their own way of doing it. That's perfectly fine. Actually, it's better to encourage them to think about any other way you can do it in your classroom. So you can share their new strategy if you haven't thought about it. That's great. What about here? So let's practice here. So I strongly recommend you to stop the video now and think about before going. I'm going to show you all the way here, but the best way to learn is practice yourself first before getting to the answer. So I'm going to ask you to stop the video for now and solve this problem by yourself and then come back to video and watch. Can you promise you can do that? Okay, let's stop for now. Okay, so how was it? Did you solve all different ways to solve the problem in here? What was the most difficult one? What was the most easiest one for you? Maybe direct modeling was easiest one because I just need to draw 11 cookies. Katie had 11 cookies. She ate 6 cookies during lunch. She must be very happy in the afternoon, right? 6 cookies during the lunch. how many cookies does Katie have now, right? So that's what she is going to have here. So she draw 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? 11 cookies, and then cross out how many of them? 6. There's action word 8. 6 of them, so I can count what's left, which is 5. So I know that it is 6 minus 11 minus 6 is 5. Okay? So counting strategy. How do you want to count the strategies in here? So they're going to start from 11, right? So I'm going to count 10, count backwards, 9, 8, 7. So I have 1, 2, 3, 4. But how many did I eat here? I have eaten 6 of them, so I have to go a little more. 10, so 1, 2, 3, 4, and 6, and 5. So this is 5, and this is 6 cookie. So my answer is 5. So I can count, right? So 10, which I ate 1, 10, 9, 8, 7, 6, 5. I ate 5. Okay. Sometimes they want to go to build up for the subtraction problem. It's very popular in the young kids classrooms. You can start from 6, but they can build up to 6, 7, 8, 9, 10, 11. So that's my answer here. Okay, that's good. What about number fact? Number fact, I already know the answer. So I know some facts somehow from my prior knowledge. So I know that 11 minus 6 is 5. Okay. What about number bond? Number bond probably can be challenging for you. Okay. That's okay. We can do it together if you're not sure. So what do you remember what we are talking about? The key important thing about number bond? Number bond, they're using what? Groups of 10. So I have to do 11 minus 6, right? And I have to figure out how can I make a groups of 10. So think about that, always putting away 10 first. So I have 11. And I have 11, but I want to break this into using 10. How can I do that? If I take away 10, how many do I have left here? 1. 11 means 10 plus 1. So make it a little easier. I want to do 10, 1 and 10. So I'm going to break numbers like this. 11 goes 1 plus 10. Do you see what I'm doing here? Because I want to use groups of 10. So I'm going to put my 10 away. I'm going to put my 10 away first. And so I'm going to take away 6. So I'm going to do 10 minus 6 first. 10 minus 6 equals 4. But I have 1 left of here, right? Because my number is 1 plus 10. I use 10 minus 6 in here. So I have to use this 1 up here. So 1 plus 4 is what? It's 5. So my answer is 1 plus 4 is, my answer is 5. Do you see? Do you understand? Do you see how it goes? So groups of 10, I want to put the 10 away first. That's something you have to think about it first. So I have 11 is 10 plus 1, but make it easier to see it, I use this one, but you can use 10 plus 1 is fine. So I have 11, 1 plus 10, and I have to take away 6. I had 10 minus 6 is 4, but this is not my answer. Why is that? Because I have 1 up here, so I'm going to add these together. So my answer is 5. Okay, good. If this is not sure, that's fine. You are going to practice same thing for the multi-digit, and a lot of times students say this makes more sense for the multi-digit number than single digit. So you have another chance to talk about it. What about derived fact? Derived fact, I want to use doubles, or yeah, you can use doubles and other numbers too. So 11 minus 6, I want to do it, but I know that 12 minus 6 is 6. Double, or 6 plus 6 is 12. So I know that 12 minus 6 is 6. But this is not my answer. Why is that? Because my number is, I starting with this 11 cookies, not 12 cookies. But I have one more in here, so I have to subtract 1 from here. So I'm going to have my answer is 5. Do you see what I'm talking about here? You may want to use 10, 5 plus 5, something like that's perfectly fine. But I have 11 and 6, so I know that 6 plus 6 is 12. So 12 minus 6 is 6. But I start from 11, not 12, so I have to take away one more. So I know that my answer is 5. The same strategy, but oftentimes for the subtraction, makes it a little bit difficult, but that's fine. We're going to practice more. So here. So the answer is Katie has how many cookies? Katie has how many cookies now? She has 5 cookies now. Okay, so if you're not sure, please rewind the video and then try to watch one more time, and I hope that's going to be helpful you to understand. So this is the single digit. So now let's talk about the multi-digit. So multi-digit problem in here. So let's read the problem together. Ready, set, go. Jennifer has 28 stickers. Her mom gave her 26 more stickers. How many stickers does she have now? So this is addition problem. I can see that 28 stickers and her mom gave her 26 more. So it is going to be 28 plus 26. So we're going to do the same thing here. Direct modeling, the most basic strategy here. So direct modeling, so what I said about direct modeling requires to the concrete model. So they're going to have base 10 block, right? Or they can, some of them using single dots to figure out that. Unfortunately, you're going to see that a lot of kids are trying to use like this to figure out this is 10. So we want to ask them to use this one, to not use this one. Instead of, we can help them to use this as 10, something like that. So they can kind of think about that. Oh, I don't need to draw all 10 circles to represent 10. I can use the number 10 to represent number 10. Right? So they can use the groups of 10 is a more effective way to do it. So counting strategies, they can use counting by ones. Unfortunately, they're going to use counting by one a lot of times. Let's get a little bit closer so you can see better. So here, I start from 28, right? And then I'm going to count 26 here by 1. So you can see there how likely they might get an error when they're counting. If they lose their track, they might be able to make a mistake. So, but they can try. They love counting strategy using their fingers all the time. So 28 and 29, this is 1, 30, 31, 32, so 1 all the way to 35, 39. So they can keep counting by ones until they count to the 26 at the end here. Okay, so whenever you see the in the classroom, if you give them problem like this, 25 plus 10, suppose that you give this problem to your kids. We expect they're gonna know, oh, this is 35 right away. Why? This is easy. Adding 10 is always easy, right? But that's not true. That's not the case in your classroom. A lot of time you'll see they're gonna do 25, 26, 27, 28, 29, 30, 31, 32. What am I doing? I'm doing counting by 1. So they're going to count tens using ones. So 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. And now I know this is 35. Right? So that's why this is one of the reasons why I asked you the video earlier talking about counting by 10 in any number going to help them to do operation. And this is a great example. Because if they know that, they don't need to even count. This is just 35. But that's not true for a lot of kids because they have to count by ones. So we need to help them to build groups of 10s. They can count by 10 easily, then count by ones. So next one is here. Counting by 10. So you see, so I have 20, need to add 26. I have groups of 10 here. 10. You see here 10 and another 10. So I added 20 and 21, 22, 23, 24, 25, 26. So my answer is 54. So 28 plus 10 is 38. 38 plus 10 is 48, and I have 1, 2, 3, 4, 5, 6 more. So I ended up 54. So far so good? Okay. So let's do a couple more things here. Very similar, very similar. So I'm going to talk about number bond and split strategy and then jump strategy. So that's what we'll talk about, and then we're going to talk about formal algorithm. So here, 28 plus 26 equals 54. This is the equation we need to figure out. So number bond. So remember what we talk about the number bond. What we are trying to do is we are trying to make closest groups of 10. So I have a 28 here. What is my next decade number? The closest 10. If I want to make closest 10, is it 20 or 30? Maybe 30 is more closer than 20 here. So I'm going to use 30. So I want to make 30 from 28. And what number do I need to have? I need to have 2 to make 30. So I'm going to regroup this number 2 and 24. So I have 28 plus 2 is 30. And I have a 24 left over. So I'm going to add those together and 54. Do you see what I'm trying to do here? Maybe this one makes more sense when talking about number, but number by I'm trying to make a groups of 10. Okay, the closest 10. So here 28, so I know the next decade number is 30. So I need 2 more to have 30. So 2 from 26 gives you 24 left over. So I have 2 plus 28, 30, and this 24 together, this is 54. Okay, what about split strategy here? So here, split here, I'm trying to use tens and ones, right? So tens and ones, I want to split the number. So 28, tens and ones, 20 and 8. 26, tens and ones, 20 and 6. So I'm going to add tens first. 20 plus 20 is 40. I'm going to add ones next. 8 plus 6 is 14. So these together, I have 54. Okay, so what's the difference between these two here? So this one, I didn't break down the first number. I used my original number 28. This one, I break the second number to make a the realist group of 10. Right? So I use 28, but I split this into 2 and 24 to make decade number of 30. For this one, I split both numbers, tens and ones. So 28, 20 plus 8, 26, 20 plus 6, and 20 plus 20 is 40. 8 plus 6 is 14. And my answer is 54. And jump strategy is very similar to counting strategy. I'm trying to use counting numbers, but the difference between counting and jump strategy is what? You see the number line in here. You don't see the number line here, but you see the number line in here. That's the difference in here. So I have 28, and I'm going to jump 20, counting by 20 first, and I have 6 more. So 28 to 48, and 49, 50, 51, 52, 53, 54. So 54 is my answer. Does it make sense? So they're pretty similar to counting by 10, but they use number lines. So you can do 28, and you can break this one in 28, 38, and 48, 10, 10. You can do that too. Or you can do 20 at a time. Same thing in here. So far so good. Do you think you can practice the problem here? So I have addition problem in here, and we talk about the modeling strategy, counting by ones, counting by tens, and number bond, make a realist group of 10, and split strategy, tens and ones for both numbers, and jump strategy similar to counting, but there's number line. So you don't need to maybe know like the matching in here, which one is which. It's better if you know that, but I want you to know at least a couple strategy you can explain to your kids. So maybe you love split strategy, but I don't think I like number bond, but that's fine. Then you can use split strategy for your kids. But as a teacher, I want you to know all of this, be able to explain and learn for yourself, be able to teach for your students. Okay? Okay. So let's talk about the formal algorithm. Your kind of favorite, because we all know traditional algorithm how to do the numbers. Oh, I know that method. Why don't we use that? We can use that. We are going to use that. So, but don't worry about it. We are going to use that. But I want to think about this. So I want to do 27 plus 15. Okay? So now, for traditional algorithm, what do we do first? Do we start from 2 plus 1 or do we start from 7 plus 5? Probably a lot of you say we're going to start from 7 plus 5. 7 plus 5 is 12. Do we write down 12 here? No? Why not? Then what do we write it down? We write down 2. Where? Here. And what do we do with 1? We're going to carry 1 up here. Right? And then what do? We do 2 plus 1 plus 1 equals 4. So this is my answer, 42. So this is the traditional algorithm we are doing in class most of the time. Then this is okay, this is very efficient. Once they master the rule, this is a very efficient way to do it. But until they master the rule, it may cause lots of confusion for kids. Have you thought about that? Why this may be confusing for kids? And think about that. How many times did we add? We add 2 times. 5 plus 7 and 2 plus 1. But we only show 1 line in here. It doesn't show any steps what we are doing here. And also another thing is that we carry 1 up here, but this is really 1 or a 10. This is not 1. This is 10, right? So we are supposed to say 10 plus 20 plus 10 is 40. So this is a place value here. So if we don't use place value when you teach mathematics, how can kids understand place value concept when they are doing addition problem? So this one hides the steps of what's going on behind the algorithm, and it doesn't explicitly say the place value we are doing here. So this is actually 20 plus 7, and this is actually 10 plus 5. Right? What about here? What about this? The same thing. We're going to do this. 27 plus 15. Okay? And we know that this is 20 plus 7. And this is 10 plus 5. So I want to do 7 plus 5 is what? 12. Can I write down 12? Why not? I'm going to write down 12. And what do we need to do now? I need to do 20 plus 10. Because I did 7 plus 5, so now it's time to do 20 plus 10, which is 30. So I'm going to add them all together, 42. Do you think you can do that? So what's the difference between here? So this one, we showed all the steps. When you add ones, I show you the step. 7 plus 5 is 12. When you add tens, not ones, tens, not 2 plus 1, 20 plus 10, I write down 30. So my answer is 42. So I use place value when I say and explain, and I showed all the steps what I did here. So kids can see what's going on behind the algorithm. And also, when we read a number or a letter or words, do we go left from right, or do we go right to left? Yes, we go right and left to right. That's more natural for kids to read the numbers, read letters, everything. We go from left to right. All of a sudden, when you teach this one, we ask them to do no. You have to go right from left, against their natural feeling. So can you start from tens in here? Why not? 20 plus 10 is what? 30. 7 plus 5 is what? 12. So I have 42. Same thing. But kids can see what's going on here more clearly than this traditional algorithm. So traditional algorithm is not bad. This is very effective only if they master the process. But it takes lots of practice to master the process, because it is not clearly show what's going on in this process. Does it make sense? Okay, good. So now it's time to practice the strategy here. So So I want you to practice strategy here. So this is for your practice. I mean, this is for you to understand the strategy here. So I trust you are going to practice this, be able to teach for your students. So I strongly recommend you stop the video and practice the problem by yourself. That's going to help you a lot to understand the process here. Okay? I'm going to upload the answer later, so I'm going to ask you to chance. I'm going to give you a chance to practice your problems, and I'm going to post the answer a little bit later so you can check if your problem is right. Does it make sense? Okay, good. Let's move on then. So I want you to practice split strategy for 85 plus 36 and jump strategy or counting by tens. So I'm going to show the process and post for you to check, but now I'm not going to show you right now, so I want you to practice. Okay, so here I have 27 plus 39, and I want you to use number band or split strategy to solve this problem and expanded the formal algorithm. So this strategy I show you here, this one here, we call the expanded notation. Why is that? Because we are using expanded notation tens and ones. 20 plus 10, 7 plus 5. We are using tens and ones, so this is called expanded notation. So let's go back to page 6 on your strategy book. So you see this is an example of expanded formal algorithm. So I want to add 248 plus 187. And what do I do here? I add 100 first. So here add the hundreds. 200 plus 100, decade number, I'm using expanded notation, and add tens, 40 plus 80. I didn't do 4 plus 8, I did 40 plus 80, which is 120. And 8 plus 7 is 15. Then I'm going to add them together, so 5, and then 30, and 4. So I know that my answer is 435, or you can from starting here. But anyway, do you see the difference in here? There's no carry or things like that. Let's just do it from add 100 first, add tens, and add ones. Same thing, another example here. So I know that this is expanded algorithm. So I have 248. Expanded notation is 200 plus 40 plus 8, 100 plus 80 plus 7. So I'm going to add 100 first, which is 300. Adding tens, not 4 plus 8. I'm adding 40 plus 8, 80, 120, and 8 plus 7 is 15. Okay, good. So this is how we can practice use expanded algorithm, expanded formal algorithm that uses expanded notation. Okay, so let's so this is for you to practice. So practice your problem. If you wanna check, my answer is correct, the way I did was correct, I'm gonna post the answer sheet key later. Okay, let's do the subtraction. It's very similar, just using the subtraction number, but we are doing the same thing. So this is the problem here. So subtraction problem, Jacob had 61 Pokemon cards. He gave 36 to his best friend Anna. How many Pokemon cards does Jacob have now? Okay, so direct modeling, what is that? Modeling strategy, they need to have a concrete object, right? So have 60, 10, 10, 10, 10, 10, 10, 61 base 10 block here. And I'm going to take away 36. But I cannot do that here, so I'm going to break this 110 into 10 ones. They're going to trade the numbers here, and then we're going to count 36, and then I have to count leftover 20 and 4 and 5, so my answer is 25. Okay, what about counting by 10? So this is one thing you will think about it. Counting by, so whenever you use a 100 chart in the earlier video, it's always important to practice counting forwards and counting backwards too. So we use counting backwards when they do subtraction and division, and most of the time division and subtraction is relatively more difficult than addition and multiplication, because we are so used to do counting forwards but not counting backwards. So if they use practice of counting backwards, they're going to help a lot with the difficult concepts, subtraction and division too. So counting backwards is a very important skill they need to practice. So I'm going to use counting by tens. So 60 to 51, so 10. And 51 to 41, another 10. And 41 to 31, another 10. So I have 30, take away 30, and have 6 more to go. So 30, 29, 28, 27, 26, and 25. So my answer is 25. Okay? What about number band? Let's talk about number band. Remember the number band, we are trying to make a groups of 10, right? Groups of 10. So I need to put away 10 first. So 61, I need to put away 10 first. So I put away 10 here. But, and what do I have left? So 61, I put away 10 up here, and my number is 51. Do you see what I did here? 61, I need my 10, because I want to use 10 to do my operation. That's number band. So I'm going to break numbers apart, 10 and 51. So I'm going to, and then I'm going to 36, I'm going to break into 30 and 6. So I'm going to do 51 minus 30 is 21. And 10 minus 6 is 4. So I have 21 plus 4 equals 25. Do you see what I did here? So this is putting away 10 is the key. Putting away 10 here. So I'm going to putting away 10 first. And then the rest is going to be other number, 51 plus 10. Why not 60 plus 1? I want to do 60 plus 1. Why is it not possible? Because we cannot take away 6 from 1. Right? So we need to regroup the numbers 51 plus 10 and 30 plus 6. So I have 51 minus 30 and 10 minus 6 is this. So I have 25. Okay? Okay, so let's talk about jump strategies. We already talked about jump strategy for addition problem. So this is very similar with, so here, jump strategy here. So I use number line. That's the difference between the jump strategy and counting strategy here. So I will use jump strategy here. So I have 61 and so I'm going to jump 30 first, or you can do 10, 10, 10, 51, 41, 31. You can do that. 30, and I have 6 more to go. 31, 30, 29, 28, 27, 26, 25. Or same thing. The only difference is the direction of the numbers, because when you use number lines, sometimes textbook shows it this way. You can go bigger number that goes away, so you can use counting backwards. Or this is easier to see how I counted backwards this way. So this way the only direction difference, but the conceptually the exactly same thing here. So I start from 61 and counting backwards about 30, or 10, 10, 10, 51, 41, 31, where I know that my numbers, I'm going to have a big jump, 30, so I can do 30, and which is 31, and I'm going to go 6 more, 30, 29, 28, 27, 26, 25. Or you can do 31 and 1 and 5, or you can do 5 and 1, however you want to break your numbers to jump. That's perfectly fine. Okay, do you see what I'm doing here? What about split strategy here? So I have 61, I want to use tens and ones, right? So, but can I do 60 plus 1? No, why not? Because I cannot take away this number from here. It's always better to make a bigger number, 50 and 11. So I'm going to break down this 50 and 11, and I have 30 plus 6. I know that 50 minus 30 is 20, and 11 minus 6 is 5. So I know that 20 plus 5 equals 25. So this one we break numbers tens, 50 plus 11, and 30 plus 6. So I have 50 minus 30 is 50, 11 minus 6 is 5. So my answer is 25. Okay, so we are going to have a practice problem. So if you are not sure, but I strongly recommend you to solve your problem by yourself. That's the best way to learn. Struggling is the best way to learn. Something is not sure, try and check the answer later. That's always helpful. Do not go to answer straightly without working on the problem by yourself. Okay? So this one is subtraction problem here. So subtraction, So remember that we talk about the addition. We start from the hundreds place, not the ones place. Can you do that for the subtraction problem? Why not? We can do that here too. That's how it shows using expanded notation. Okay, so here I want to do 932 minus 356. Remember that this is not 932. No 932. This is 932. This is not 356. This is 356. So I'm going to, I know that this number is breakdown 300 plus 50 plus 6. Right? That's 356. That's what we are going to do. So I'm going to take away 100 first. 932 take away 300 is what? 632. So now I need to take away 50. So 632 take away 50. So now can I use counting backwards by 10? Why not? So 632, 622, 612, 602, 582, 92, 582. So I take away 10 5 times. 10, 10, 10, 10, 10. So I have 582 and I have 6. So I'm going to take away 6 or take away 2 first and take away 4 later. So 482 minus 2 is 480 and 4 more is going to be 576. Okay, so I have 356 is 300 plus 50 plus 6. So I'm going to take away 100 first, 50 and then 6. So I still use tens and ones and I use numbers by 10. Same thing in here. Same example here. So 932 minus 356. So this number is 356. It's the same as 300 plus 50 plus 6. And subtract 100 first and subtract tens and subtract ones. Okay. So I want you to look at this, how they did it. This is the way they can do they did subtracting, counting by 10 backwards here. So 50, I want to do 632, minus 10 is 622, minus 10 is 612, 602, 592, and 582. So my answer is 582. Then I had to take 6 more. This is how I subtract 6 more. Okay. Okay, it's now time to practice. So your strategy book page 12 and 13. There's a couple numbers I gave you here and I want you to practice this one. 71 minus 28. Number bond or split. If you do the both, that's the best. So you can master all the strategy we talk about it. Counting by tens or jump strategy for 71 minus 28. And here, number bond, 65 minus 37, right? So I want to think about how number bond look like with these numbers in here, 65 and 37. Remember that we want to putting away 10 first. So 65 putting away 10 first is going to be 55 plus 10, right? And minus 37. How are we going to do that? And expanded the standard algorithm. So remember that we have this number, keep this number, 455, but I have to break this number down, 170 and 9. So I'm going to take away 100 first from 455 and 70 from the rest and 9 from the rest. So this is something you can think about it. Okay. Okay. So this video is kind of long to go over all the strategies here, but this strategy is really important because this is basically what we are going to teach in your classroom. So something is not clear, you don't know how to do that, I recommend you to re-watch the video some part until you understand the concept and do the practice problem and check the answer key. But not now. So I'm going to give you time to do it. Before finishing up this video, I'm going to share one strategy I learned from my own students. His name was Jose. And everybody was impressed by his strategies. That's why I'm going to share and I'm going to stop for this one. Okay, do you see here? Okay, my problem is 1000 minus 34. So I'm gonna try to solve this one. And you probably know how I know I can do how this in my head. Probably no. This is a kind of difficult problem. Why is that? Because I cannot take away 4 from 0. I cannot take away 3 from 0. So there are going to be a lot of regrouping here. Remember that I want to mention this one here too. When you're talking about borrow a number, so I have here, I'm going to borrow a number from here, borrowing from the number, the next place value. Do we really borrow a number? We never give them back, right? If we borrow something, we need to give them back, pay back. But we don't do that. So this is not a good word to use in borrow. That might confuse kids conceptually because we are not actually borrowing. What we are doing is we are regrouping the numbers. We are doing regrouping. Right? So that's we are trying to use in math ed right now, regrouping the word numbers, not borrowing or carrying. Because it doesn't tell you what we are doing actually in the algorithm, right? So we are trying to be grouping the numbers. So whenever you do this one, to save your time, a lot of you say, you can teach me how to do this, but they're gonna do like this, 10, and this is 10, but this is 9, this is 10, and this is 9, because of all the borrowing process. Right? So I'm gonna do, so 10 minus 4 is 6, 9 minus 3 is 6, and 9, so my answer is 966. Well, I promise you, this is very difficult for the kids to show why we are doing this. What does this all number mean in here? Why this is 10, but this is not 10, this is 9? Why this is not 10, this is 9? Why is that? What does it mean? Can anybody tell me what does it mean? This means, what does this number represent? We are trying to regroup this number 1000 to 990 plus 10. Do you see here? That's what we are trying to do. This is 990 and this is 10. So that's what we are trying to regrouping in here. 990 plus 10. This is what we are doing, all the carry and borrowing the stuff in here. This is actually what we are doing here. So, I'm going to share my student strategy here. So what he did, when I give this problem, do we have the same answer here? Yes, we have the same answer, 966. But what did he do first? His name was Jose, so I promise I'm going to share your name strategy for my class, and that's what I do. So, what did they do here first? 1000 minus 1 is 999. Why he wanted to make this here? Because if I make 999, I don't need to worry about any borrowing or stuff. I can take away all the numbers from 9. So he knew the relationship. 1000 minus 1 is 999. This is a big concept, big jump. But knowing this knowledge makes everything easy for him to do it. So I take away, this is easy, 965. And why do I add 1 up here? Because I changed my number from 1000 to 999, so I know that I have to add 1 number back to 966. Okay? So whenever I share this strategy with the students, a lot of what I saw their eye opening, but this is all about the number sense. If he has a really good number sense, they can drive his knowledge, be able to solve the problem in a very creative way, invented algorithm. This helps a lot of the other kids to understand what does this mean actually, and why he can do this. What's the difference between these two? Was really a good lesson for the whole class. Okay? So I always share this strategy and this episode with my student teachers like you, the teachers like you, so you can understand kids' thinking and be able to apply this knowledge in your classroom. Okay? So thank you for listening all the long video today. I usually don't do this, but I want to show all the threads at once so you can see the multiple different way of the same problem. That's why I move everything at one video. So hope you enjoy the video. If it feels it's too long, you can stop in between and solve the problem by yourself, and you can continue the video. Okay? Okay. So thank you for watching this, and then I'm gonna post the answer sheets later. And if you have any question, please let me know. Okay? Thank you. Bye-bye.